Hello and good morning to Madam Faranas. The item that we choose to invent in this assessment is a fan. In this presentation, we will cover the relation between fan with the rotational mechanics and thermal physics theory. We will also cover the component of need and approach. The rotational mechanics or the type of motion of a fan are rotational motion. Type of rotational motion of a fan is motion of a fixed axis, which means the fan blades rotate in a circle with a central fixed point. For the thermal physics part, the spinning blades of a fan will suck the hot air from surrounding, then it will be accelerated and pushed downward into the room as a breeze. For the fan that we will invent, the blades will be made from plastic. The reason why we choose plastic is because it can be molded into variety of shape, didn't easily rust, easy to clean, and lighter in weight. Lastly, more quiet in sound. In addition, the fan blade design will be airfoil, which is more efficient and can be employed in medium to high pressure industrial application. This fan can be used for domestic use at home because it's improved the efficiency of airflow for a whole house. It's also high quality in aesthetics due to its easily molded into shape characteristic. The fan also can be used at school because it's more quiet in sound, which is suitable for library and classroom. It's also much more affordable to apply for every room at school.
Problems usually occurs after 3 to 5 years of usage. A lifespan of a fan usually lasts depending on the usage. On average, ceiling fan usually lasts until 6 to 10 years, while standing fan lasts up to 3 to 5 years. However, not cleaning and not checking on the fan regularly may be the reason that decreases the lifespan of a fan. People usually experience a problem with a fan when the fan is already used for many years. About 7 out of 10 people complain about the same problem. Problems like noisiness will happen due to loose parts or a damaged motor. Not only that, wobbling or shaking of a fan may also happen due to an unbalanced blade or a loose screw. Fan speed issues are one of the popular problems, which caused by the switch or the capacitor. Using an airfoil fan blade may be better, but it has a higher cost of production, which will make the price more expensive than a regular fan blade. It may cause big problem to some users. For example, problems like noisiness will cause disturb during sleep time. Some people may be unbothered with the sound, but people with misophonia problem, which is a condition which a person is sensitive to a sound, will suffer and disturbed by the noise coming from the damaged fan. Besides, it will cause tiredness on the next day due to lack of sleep. This situation will cause bigger problems like health problems to users if not taken precaution. As for the second reason, wobbly or shaky fan has to be repaired or replaced with a new one, or it may be dangerous because it is most likely to fall down and injure anyone near the fan due to loose screw or unbalanced blades. This is why it is important to change to a new fan. If need is not met, then problem will be faced. For example, blades that are made from plastic are not preferable at extreme temperature. This means that plastic can't be exposed to heat or it will start to melt due to atoms' inability to vibrate quickly. This situation causes a plastic blade fan can't be used for industrial purpose because not only it is not big enough, but also it is not heat resistant to be used as industrial equipment. Lastly, for an airfoil fan blade, like stated before, it has higher cost of production, which most likely to be sold at an expensive price. If an airfoil fan is being sell to be a fan for daily use, sales will potentially go lower and will cause a loss to the manufacturer because of its expensive price that makes most people can't afford it.
The unique approach to meeting portable hand fans need in terms of rotational motion was aerodynamic blade design, which means that optimizing the hand fan's blade design may enhance its airflow efficiency. Engineerable fan blades that are curved and slanted to maximize air circulation using rotational motion and fluid dynamic concept. The blades form and pitch may be adjusted to reduce air resistance and turbulence, resulting in smoother airflow and more effective cooling. And for thermodynamic terms such as heat dissipation mechanism can be used to address the heat created by the fan motor during operation. Heat dissipation methods such as heat sink or conductive material can assist disperse heat and keep it from harming the user comfort. This guarantees that the fan stay cold to the touch even after extended use. Apart from that, there was portable power management. It is critical for portable hand fans to consider the thermal physics component of energy efficiency. Power management solutions that reduce energy consumption and increase battery life and can improve the mobility and usefulness of the fan. This can be accomplished by sophisticated power saving mode, low power motor, or the use of high energy density rechargeable batteries. In terms of rotational motion, our recommendation for this portable hand fan is that its general design, including the blade form, pitch and angle, be optimized in order to maximize airflow effectiveness and reduce turbulence. This guarantees efficient cooling capability. In terms of thermodynamic, the portable hand fan incorporation of effective heat dissipation mechanism provide the answer. To make it easier for heat to be transferred away from the motor, we can replace heatsink or thermally conductive material there. In order to dissipate heat and maintain a cool working temperature, the fan shell can also be designed with ventilation aperture to heat conductive fins, assuring user comfort and reducing overheating. In addition, putting in place power management system that maximize energy use and battery life is the correct solution. Intelligent power saving modes that change the fan speed or lower power usage during period of inactivity can be created by us. Choosing low power motor or using rechargeable batteries with a high energy density can further increase the runtime and mobility of the fan. They have many technician issues to solve, such as the fan effectiveness greatly depend on the motor choice. To successfully convert electrical energy into mechanical motion, we should select motor with minimal energy loss, high torque, and high power efficiency. Aside from that, thermal issue might be brought on by the heat the motor generated while it is running. Effective heat dissipation methods are necessary to prevent overheating and provide user comfort. We may employ heatsink, thermal pad, or fan to improve heat transfer and cooling.